Hi everyone, welcome back. So GFG problem of the day today is find length of loop. This is a very common and widely asked question. There are similar versions of this question, that is to find length in the linked list. This question is asking for the length of that loop. Cycle detection algorithm is used in this question. So the question says we are given the head of the linked list. Determine whether the list contains a loop. If a loop is present, return the number of nodes in the loop. Otherwise, return 0. So today we shall discuss solution of this question using two approaches. In first approach, we will use extra space, that is, we will discuss the solution using Hashmap because this will help you to have a better understanding of Hashmap functions and its usage. Secondly, we will use the algorithm, that is slow fast pointer approach, Floyd cycle algorithm. So moving to the first approach, that is using Hashmap, that is simple. So what shall we do to find the loop and the length? We can create a hash map. We can keep the node and its index, what index it is appearing. Now we will traverse our linked list. If that node is present in, if the node that is coming next is present in our hash map, that means there is a loop. And how shall we get this length of the loop? The current index minus the stored index in the hash map, that difference will give us the length, right? Because see, what is the length? First index, second index, third index, fourth index, fifth index. Now this will be coming current index as 6. Now 6 minus previous stored index. 6 minus 2 gives us 4. So what is the length? 4. So that is the simple brute force approach that people use using Hashmap, because Hashmap gives us the search time O1, reducing the time complexity. Moving to the solution, we have created a map, simple hash map. What we will store a node and the integer index of that node. So initially the index shall be 0. Now what we have to do, we have to traverse our linked list. So while head is not equal to null, what is the first thing that we have to do? We have to check whether head is present in our hash map or not. If it is present, we just have to return current index minus the previous stored index. So this is the loop length. Otherwise, what we have to do, we just have to put the node and its index in our hash map. So map.put add comma index. So this was the contains key was the function to check whether the key is present in the hash map or not. So this is the usage of hash map. Now what we have to do, we have to move the head to the next. Head is equal to head.next, and index we will increase. We have increased our variables. Now if we do not get any time that the key is contained in the map, means there is no cycle or no loop in the linked list. So for that case, we have to return 0. So we have returned 0. So this was the simple solution using Hashmap. But the problem with this solution is there is actually no problem, but slight optimization can be done, as this approach uses extra space of ON, but we are expected to use O1 extra space. So how shall we do that? We will move to the slow fast pointer approach, that is the Floyd cycle algorithm. So what is this slow fast pointer approach? So this approach says use two pointers. There is a tortoise and hare approach, where we can consider one pointer as slow, another as fast. Slow pointer will move one step and fast pointer will move two steps. Now consider you are running in a circular ground. One is running at speed 1 and the other is running at speed 2, other at least is running at speed 2. So it is bound that after some time the uh, fast athlete will cross our slow athlete, right? Because the ground is circular, so they will meet again. So this is the same thing that we will use in this question. Slow pointer and fast pointer. Fast pointer is bound to meet the slow pointer at some point of time. If it does not meet the slow pointer, that means there is no cycle, means the ground is not circular. If it meets, means there is surely a cycle in the linked list. So after finding that we have got a cycle, we have got one slow pointer index. How shall we find the length using this approach? That is the question that comes to our mind next. Suppose they are meeting here, or they might meet here, or they might meet here. We have just got that, we have got a cycle, but we do not know the length, right? So how shall we get the length? So one thing we know is that the cycle is surely present. Now if we keep a variable index and while and traverse the list while we do not reach the starting point again, so we shall get the length of the loop or the length of ground. If we move from that position, for again we know it is a circular ground, to that position, we shall find the distance, right? So same we will do. Suppose he is slow and fast pointer meet here, we will traverse our linked list till we do not reach this point again and keep counting the length. So moving to the solution, we have created two pointers, slow pointer and fast pointer. Initially they are both at the starting point head. Now till when we have to do, till fast is not equal to null and then fast dot next is not equal to null, because if both of these, if the fast or fast dot next reaches null, means there is no cycle and we have come out of our loop. Because if fast dot next is null, where shall we move next? We traverse it twice, this cannot be null. If these reach this condition, means there is no cycle. Now what's the first step? First step is to increase our pointers, where means slow is equal to slow dot next, fast is equal to fast dot next, means slow is moving one step, fast is moving two steps, two nodes. Now if slow is exactly equals to fast, if these two pointers meet, this means our cycle is definitely present in the linked list. There is a loop in the linked list. We now have to find the length. So for length, what we discussed, we will keep our length initially equal to 1 because we are at slow. We will keep a temporary node that will be equal to slow dot next. Now till temp does not become slow again, we will keep moving the temp and keep counting the length till we do not reach our slow pointer again. Cycle is definitely present, so this will definitely reach slow again. We keep counting the length and after that we return this length. This is the length of the loop. If we come out of the while loop, means there was no loop in the linked list, so for that condition we have to return 0. We have returned 0. So this was the slow fast pointer approach to find the length of the loop or to detect if there is a cycle in the loop linked list or not. So I hope you guys would have got the idea. Thanks for watching the video. Have fun. Bye.